Newton's biggest regret was a question he couldn't answer. The sun is 93 million miles away. How does gravity cross the void? Newton noted, "No arm, just gravity." He didn't know how to explain it. He said whoever could answer this question would be considered brilliant. 2 centuries later, a clerk stunned all with an answer. This man was Einstein. Gravity isn't a force, it's illusionary. The weight you feel right now is actually your floor pushing up against you. Confused? Don't worry. By the end, you'll understand everything, forever changing your perspective. Our story begins in 1687, when a professor in England published a book. The title of his book was quite long. Principia by Isaac Newton. This book altered the course of human civilization. In it, Newton did something unprecedented. He unified the stars in the heavens and apples on Earth under one set of rules. Above and below were seen as 2 separate worlds. The sun, moon, and stars' movements were sacred and perfect, unrelated to Earth's motion. Newton said no, they all follow the same laws. Apple falls, moon orbits, both ruled by gravity. Any 2 objects with mass attract each other. The greater their mass, the stronger the attraction. The farther apart, the weaker the pull, simple yet powerful. With this single formula, humans calculated how planets orbit the sun and when comets would pay a visit. Tides rise and fall daily. We use them for satellite launches and moon missions. Newton became a deity in science. His theories reigned for centuries unchallenged. But Newton himself was well aware that this theory had a fatal flaw, and he couldn't solve it. The problem: 150 million km of emptiness between Earth and the sun. How does the sun's gravity reach Earth across 150 million km? Sounds like magic, not science, indistinguishable from telekinesis. Newton openly admitted in his book, "I can't explain this problem, but the laws work anyway. Let's leave it at that for now." Future solvers will amaze. Even Newton couldn't crack it. 2 centuries passed, many minds failed to solve it. Until a young man working at the Swiss Patent Office between 1905 and 1915. Einstein upended Newton. Let's discuss him. Many know him from the tongue photo and his poor math skills as a child. Einstein excelled in math, scoring near perfection on his entry exam. The math rumor may come from his early exam failure in humanities. This misinformation spread as if it were about his mathematical abilities, which is quite unfair to him. Einstein struggled to find academic jobs youthfully. He worked as a clerk at the Bern Patent Office, reviewing patents, but this guy. He researched actively, publishing 4 key papers in 1905. That year, dubbed Einstein's miracle year, his papers changed the world, introducing special relativity. E equals mc2, but more was to come from 1907. Einstein pondered, Newton's gravity contradicts special relativity. Information can't exceed light speed, yet gravity acts instantly in Newton's view. If the sun moved, Earth would feel it. Einstein said this was impossible. Einstein spent 8 years mastering advanced math tools. In 1915, he published General Relativity. Gravity isn't a force, it's space curvature. Questions. But don't worry, let me explain. Imagine taking a taut rubber sheet and laying it flat. Place a heavy bowling ball in the center, which will cause the sheet to sag into a depression. Roll a marble on the sheet. It rolls toward the ball. Not because the ball is pulling it, but because the rubber sheet itself is curved, and the marble simply follows the curve of the surface. As Einstein said, this is how our universe operates. The universe we live in is not an empty box. It's a vast membrane, a four-dimensional fabric of space and time. Celestial giants warp spacetime around them. Earth isn't being pulled by the sun. It simply follows the most natural path through curved spacetime. That most natural path just happens to be an elliptical orbit. You might wonder if I am standing on the ground. Why do I feel like I'm being pulled down? There's always a force pulling me towards Earth at every moment. Einstein would say no. You're feeling it wrong. The truth is your body actually wants to move downward along the natural curve of spacetime. It wants to fall toward the center of the Earth, but the ground stops you. What you feel as weight isn't the Earth pulling you. Ground pushes back, preventing descent. Earth vanishes. You'd float freely, feeling no force at all. On a train, you feel force only when accelerating. Gravity works the same way. In free fall, you don't feel gravity. Astronauts float due to this principle. This theory sounds too abstract and counterintuitive, but it is true and has been repeatedly verified countless times. In 1919, Eddington observed starlight deflection during a solar eclipse. Light bends near the sun, confirming general relativity. News of this discovery propelled Einstein to global fame overnight. Mercury's orbit anomaly and sun-deflected starlight only explained by general relativity. Today, GPS clocks need relativity adjustments or errors pile up by kilometers daily. This fix keeps your route from third to fifth. Einstein's theory predicts black holes and grav waves. You will navigate from the third to the fifth ring road. Black holes, gravitational waves, and lenses exist. General relativity explains these phenomena, tested rigorously for over a century. It remains our best understanding of gravity to date. Well, after discussing the fundamentals of relativity, you might wonder. The connection is profound. We are now at the heart of the matter. In Newton's theory, gravity arises from mass. Mass produces gravity. No mass means no gravity. Simple and straightforward for all ages. However, with Einstein, things become far more complex. Einstein's field equations tell us that it is not just mass that curves spacetime, but a quantity called the stress-energy tensor. Energy, momentum, and pressure curve spacetime. Mass is just energy. E equals mc squared. Energy as mass times light speed squared. This formula reveals a startling truth. At their core, mass and energy are fundamentally the same thing. Mass and energy are the same. Energy in matter, as shown by atomic bombs. Energy manifests as mass. In accelerators, new particles emerge. Mass is energy. Ice melts to water, water freezes back. Both are H2O. Mass becomes energy, energy becomes mass. Essentially, they are one. What does this mean? Spacetime bends in response to energy, including mass. Could other forms of energy also curve spacetime to generate gravity? The answer is undoubtedly yes. Let's start with light. In everyday life, light seems intangible and weightless. It illuminates the world and warms our skin. Yet you cannot grasp or weigh it. But does light have energy? Of course it does, when sunlight hits your face. Warmth from light heats your skin. Plants use it for photosynthesis. Sunlight becomes energy stored as sugar. Panels turn light to electricity. Light carries energy. Light has no mass. Photons are massless. You cannot hold a photon still to weigh it because photons are always in motion, perpetually traveling at the speed of light. They never stop. Photons carry energy, thus energy equals mass. So in a sense, light does have an equivalent mass. Now, if light has energy, can it bend spacetime and generate gravity? This is proven by Einstein's equations. Laser light curves spacetime slightly. This curvature is so small it's almost immeasurable. Theoretically, intense light exists. Confine a powerful laser in a small space. It traps light, warping spacetime. Forming a black hole composed entirely of light, devoid of any matter and lacking traditional mass, it is pure light. Yet it generates strong gravity, seemingly impossible but possible by physics. We lack the tech. A theory confines light in mirrors. Box gains measurable weight as photons bounce inside endlessly. The more light is contained within it. Why? Because trapped light possesses energy. Energy warps spacetime, and warped spacetime manifests as gravity, so the box appears to have gained mass. The box isn't filled with sand or iron. Its gravity still increases. Light has gravity without mass. Light generates gravity. Pressure does too, astonishingly. You might say that pressure is just things pushing together. What's so remarkable about that? The remarkable part is pressure curves spacetime, not the substances generating it. This sounds too abstract, so let me use a star as an example. A star like our sun. It's a huge plasma ball with massive gravity. Why hasn't the sun collapsed? Because of its core. Hydrogen atoms fuse into helium, releasing tremendous energy. Generating high temps and pressure. Outward force counters gravity, achieving balance. So the sun can steadily burn for billions of years. Up until now, this is common knowledge, but what follows is quite bizarre. In Einstein's theory, those outward forces actually increase the sun's gravitational field. Pressure resists gravity, yet enhances it. No contradiction in general relativity. Where pressure is a form of energy, and any form of energy curves spacetime, so the greater the pressure. Spacetime bending increases gravity. Resistance enhances its strength. In extreme bodies like neutron stars, it becomes crucial. Neutron star density is vast. One spoonful weighs billions of tons. Neutron stars have intense gravity due to high density and internal pressure. But here's the question. Is there such a thing as nothingness that still exerts gravity? Emptiness has weight, a stunning cosmology discovery. This sounds like a Zen koan, but it's not philosophical. It's a factual observation. Einstein's 1917 mistake marks the start. Einstein used his equations for the universe, then seen as static and unchanging. The universe simply existed as it always had, neither expanding nor contracting from past to future. Einstein's math showed the universe expands or contracts, not stays still. The universe is either expanding or contracting. It cannot be static. Einstein didn't believe this outcome and thought there must be an error in his equations. He added a constant to keep the universe stationary, naming it the cosmological constant. Hubble observed distant galaxies in 1920s with the largest telescope. He found galaxies redshifted, meaning they move away from us. Faster receding for distant galaxies means the universe expands. Most galaxy spectra redshift, indicating movement away. If he trusted his math, he foresaw cosmic expansion predating Hubble. This would have been a Nobel Prize-worthy achievement. Instead, he discarded it himself. But the story doesn't end there. Nature had prepared an unexpected surprise for Einstein. In 1998, two independent teams of scientists. This is a Nobel Prize-worthy mistake, but the story continues. In 1998, scientists revealed a shock to Einstein. Strange discovery in distant type Ia supernovae. They measured the universe's expansion deceleration. Gravity should pull all cosmic matter together. The expansion should slow, just as a ball thrown up falls back. They sought to measure the cosmos' deceleration, but found it accelerating instead. The expansion wasn't slowing, it was accelerating. It defied intuition and physics. Unless there was some unseen force pushing the universe outward, this phenomenon made no sense. Scientists named this unseen force dark energy. Dark means we can't see or know it. We can only infer its existence through the gravitational effects it exerts on visible matter. Dark energy is the energy in empty space. A vacuum isn't empty. Quantum mechanics proves it. As the universe expands, the density of matter diminishes. However, the vacuum energy remains unchanged. Space doubling doubles vacuum energy. As the universe expands, vacuum energy increases. Vacuum energy drives expanding space, speeding up as it grows. Current observational data tells us this. The universe's energy is mostly in ordinary matter, atoms, elements, and all objects made from them. Stars make up 5%, dark matter 27%. Stars will fade, burning out one by one, new ones rarely forming. Black holes evaporate, ending in a cold, dark universe. An empty expanse that continues to expand without end. Physicists refer to this as heat death. It sounds quite bleak, doesn't it? What if dark energy grows stronger over time? Expansion accelerates, tearing apart galaxies, stars, planets to disintegrate all structures in the void. Physicists call this scenario the Big Rip, a more violent end to the universe than heat death. If dark energy weakens over time, expansion might slow down, stop, or even reverse. The universe contracts, collapsing into a point. This may trigger a new Big Bang or mark its end. Physicists call this nothingness governs all. The fate of the universe is written in the weight of the void. We have now discussed light pressure. The new Big Bang might be a complete end. Physicists call this the Big Crunch. You see, nothingness is nothing. Nothingness rules, the universe's fate lies in emptiness, light pressure covered. Empty space exerts gravity, a massless form you may know from news. Gravitational waves detected September 14, 2015. A signal from distant planets, traveling 1.3 billion years, reached Earth. Two massive black holes merged far away, one with 36 suns, the other 29. They had been orbiting each other for countless years, their orbits tightening and speeds increasing until the final moments. At near light speed, they collided, merging into a black hole with 62 solar masses. But 36 plus 29 equals 65. How? This sentence is 41 characters long. They became under the 7.3-second mark while maintaining the core facts and conclusion. 3 solar masses in energy equate to roughly 5 times 10 to the 47th joules. This number is so vast, hard to fathom its scale. In a fraction of a second, the collision released immense energy. This energy exceeds the universe's starlight. Where did it go? It became pure energy. It didn't become light, heat, or particles, just gravitational waves. Imagine throwing a stone into a pond and watching the ripples spread outwards in all directions. Gravitational waves behave similarly, except instead of water rippling, it's space-time that is being stretched and compressed. Vibrations spread at light speed, traveling 1.3 billion light years. Before complex life, Earth was barren. Then in 2015, they arrived at our solar system. As they passed Earth, they stretched then compressed space, alternating directions. Humans detected this change using a highly precise instrument called LIGO. What is LIGO? It contains 2 4 km L-shaped vacuum tunnels with lasers. The device detects changes in a 4 km distance by 1/10,000th of an atomic nucleus when gravitational waves pass through. That's 0.0000000000001 meters. For perspective, the proton diameter is 10 femtometers. LIGO detects changes 10 times smaller. Detecting changes smaller than a proton, over 4 kilometers. This precision is like measuring from Earth to Proxima Centauri within 1 Earth radius or a human hair's width. Humans are remarkable. This discovery proves gravitational waves have no mass. They are not matter. They are vibrations in space-time geometry, pure curvature propagating through space. Energy from 3 solar masses, 1.3 billion years away, made Earth's mirrors wobble. Gravity doesn't need mass. Space-time vibrates and transmits energy. Gravity travels independently through the universe since detected, unmatter involved. Scientists detect dozens of gravitational waves from colliding black holes. Merger of neutron stars, collapse of stars. Gravitational waves detect these extremes. Gravitational waves reveal how gold, platinum, and uranium form in neutron star collisions. Gravitational waves show more massive black holes exist, revealing invisibilities beyond light's reach. Before gravitational waves, we saw light. Now we hear darkness. Yes, there can be gravity for light and empty space because they contain energy. Gravitational waves carry energy. Mass still governs attraction. Energy creates gravity. Mass is just common energy. Einstein showed that spacetime curves for any form of energy. Energy rules. Mass is just disguised energy. So what exactly is gravity? It's not a force, nor an invisible tether pulling you to Earth. Energy is mass in different forms. So what is gravity? It's not a force. It's not an invisible rope tying you to the Earth. It is the very shape of spacetime, a geometric projection of energy. It shows the universe's path, sitting curved spacetime down. Earth orbits the sun, dragging you along its curved spacetime path. When light bends as it passes near massive objects, it is taking the shortest path through curved space. Gravitational waves ripple spacetime as they spread through cosmos. Energy warps spacetime, the core truth. And everything moves along this warped spacetime. This is Einstein's universe, a universe that operates without force. A universe where light speed limits motion, geometry rules, and gravity forms. At this point, you might wonder about an imaginative question. Could we humans create our own gravity? Not through mass accumulation, but through light and energy. In theory, focusing a powerful laser into a small space is possible. You can curve spacetime by controlling vacuum energy. You can manipulate gravity in theory. But in practice, achieving them is incredibly difficult, maybe even impossible for all time. To generate a detectable gravitational effect requires immense energy, beyond current tech. Our most powerful lasers have minimal gravity, akin to dust. Practical use needs more energy. Space travel may soon be reality. Remember what we learned today. Gravity belongs to energy. Light, matter, motion, energy, all. Heat is energy, even emptiness itself. The vacuum is energy. Space-time listens to all their voices, then bends in response. This is the true face of our universe, not an empty box filled with some material, but a living curtain shaped by everything on it, including lights and actors, even the stage itself. You sit, stand, or lie down while scrolling through your phone. The floor beneath you pushes against you, resisting spacetime's curvature, pulling you down. What feels like Earth's pull is the universe guiding you. Friend, this direction is down. If you have a chance to look up at the night sky and ponder, every beam of starlight slightly warps spacetime. Each burning star uses light and heat to rewrite the geometry of the cosmos. Distant black holes collide. Gravitational waves cross billions of light years toward us. The vast emptiness is pulling apart the entire universe with its weightless force. This is gravity. All of this does not require traditional mass as we understand it. All that's needed is one thing: energy. Energy is everywhere, so gravity is everywhere too, though we used to be unaware of it. That concludes today's story, from Newton's apple to Einstein's spacetime. From photons to LIGO to the fate of the universe. This journey spans over 300 years of physics history. I hope that next time you feel your weight, you'll remember today's story. Gravity guides you, not Earth's pull. It speaks energy's language, not just mass. If you found this enlightening, please like, follow, and save. Your support fuels my passion for science communication. See you next time. Oh, one more thing, I'll leave you with a question: if emptiness has weight, then does the concept of having no weight exist in this universe at all? If it does, what is it? This non-existence prompts your reflection. The answer is more intriguing than the question.